Welcome to Pomodoro Joe for January 26th, 2023. Today we're looking at LeetCode problem 787, cheapest flights within K stops. This is a medium problem, and I won't bother reading the whole statement, but basically this is a real-world problem. You have some source city that you start in, and you're trying to get to some destination city, and in between you have a number of flights you can take. But you're a cheapskate, so you want to spend the least amount of money possible, but you're also kind of a creature of comfort, so you don't want to have too many stops along the way, at most K stops. So, given a list of flights, how do you get from the source city to the destination city in fewer than K stops by spending the least amount of money? So that is our goal. All right, let's put 25 minutes on the Pomodoro timer and get started. For this one, I am going to use recursion. Oh, the magic of recursion. So much fun. So we're going to have some result, start at -1, and we will return our result. So one thing I didn't mention, if you cannot make it to the destination city, you need to return -1. All right. So with any recursive function, you need to have your base case. So what are our base cases here? We have two. So the first base case is, what if we're at our destination city? So if our source city is equal to our destination city, we're here, we're done, and we can return, I don't need those. So if we're at our destination, we can just return 0. It costs us 0 to get from our source to destination because we're already there. Sweet. All right. Now the other option is we've had too many stops and we just give up. So if K is equal to 0, but that's not totally true because the number of stops is actually 1 fewer than the number of flights. So for example, if you have 1 flight from source to destination, there are 0 stops in between. Yes, there are 0 stops, but there's been 1 flight. So we can say if it's less than 0, then we can't make it, so we return -1. Okay, so base case is out of the way. What is next? Well, the next thing is we have to figure out from this source city, what cities can we get to? So we'll have some list of, we'll call it available flights. All right, and that's going to be a list. And so at this point, we'll have to go through and figure it out. So for flight in available flight, no, for flight in flights. So we have this list of flights. And the list of flights is a list of lists. And the internal list is from, to, and price. So that's from city, to city, and the price. Now, I think in my available flights, instead of storing the entire structure, I'm just going to store the index. So we'll do for the index and flight in, and then here's a trick. You can do, say, enumerate. So E-N-U-M, yeah, enumerate our flights, and that will return the index and the value. All right, so for every index and flight in our enumerated flights, if our flight, if I could spell, if the flight's source city is equal to our source city, well then this is a flight we can take. So we will add that to our available flights. And we're just going to store the index. All right. With my bad typing, it's going to take a little bit longer. All right, so available flights. Now we say for every available flight, let's find the cheapest option. So for flight in, actually this is the flight index, let's be honest. So for the flight index in available flights, the flight itself will be the flight at flights at the flight's index. Okay, so now we've got our flight. What do we do with this? Well, we'll recurse. So our option is to take the flight. So let's take this flight and we will basically find the cheapest price. Let's grab that. And I need to call self. So we'll find the cheapest price. We still pass in the same n, same flight. Now our source is going to change a little bit because we're flying from now the destination of this flight. So that's going to be flight at 1. But we still are trying to get to the same end destination. And we've taken one flight, or we've had one stop, so we have to take 1 off of the k. Okay, now that we have an option, if that option is -1, meaning we couldn't reach our destination, then we'll just continue. We're not going to even try to get on that flight. Otherwise, the total cost so far is going to be the flight that we just took, which will be flight at 2, plus the remaining flights. All right, now we can set our result, and that's going to be the minimum. We want to find the minimum flight cost, so that's going to be the minimum, our result, or this total cost. But that's only if, let's see, I didn't even define a result. I did, -1. That's only if the result is not already equal to -1, because -1 will be minimal. We don't want to replace -1 with -1. So if we don't already have any result yet, we'll set it to this total cost, because that is the cheapest we've found so far. And then at the very end, we'll return our result. Okay, so that's it. Let's see how well we did. All right, let's see. Available flights is not defined. I missed an S. There we go. Try that again. And we pass. So, recursive algorithms are notorious for taking a lot of time. I will submit this, but chances are slim that we'll actually pass within the time limits. But don't worry, I'll show you how we can fix that. Man, that is slow. And we didn't pass within the time limits. Not too fair. We have a couple things we can do. First thing we can do, you can see every time we go through trying to find available flights, we basically have to go through our entire list of flights every time, finding which ones start from this source city. Well, instead of doing that, let's build out, let's see, where will I put this? Yeah, we want something essentially outside of our recursion. We're going to build a map. So it's a dictionary where the key is the source city. So given the source city, give me back a list of all the flights that I can take from this city. We just want to build that once. We don't have to do that every time we go through this recurse. So the first thing we'll do is we'll create an internal function that is essentially the same function we have here, only we can do some processing outside of it first. So we will have defined find cheapest price recurse. And so a couple things we don't need in our internal recursion. We don't need the number of flights. We can ignore that. We won't be using this flights. We'll still need the source, and we'll still need the destination, and we will still need our number of stops. Okay, so now I'll grab everything that's in here and I'll indent it, hopefully. All right. And then from the calling function, we will just return this new recursive version, starting with the same source, same destination, and same k. Now, if I run this, it should still all work. We didn't really change anything. So that still all works. So what can we do outside of this that will help us? There are a couple things we can do. The simplest, I'll show you right now, is actually like sort of a Python trick. This is dynamic programming. So from func tools, let's see, import cache. So one thing we can do here is we can cache our values. Essentially what this will do is say, given the same inputs, we'll always have the same output. And once we've calculated it once, we won't have to calculate it again. We'll cache that answer. And so if we get the same inputs next time, we'll just return the answer we've already calculated. Now this helps us here. It would not work on this outer function because things like flights, lists of lists, those are not cacheable. So it works for the internal recurse function. It will not work for this external function. So one thing we also have to change in our recurse function here, we won't be calling our main function. We will be calling this internal recursive version of the function. All right, let's run that and see how well we do. And it looks like I have a typo. Find cheapest price recurse. Oh no, it's because I'm no longer required to pass in flights or n. Great. Everything else stays the same. Okay, so that still works. I bet with this caching, we might even pass our time limit restrictions. Hey, we do. We pass. It's not a great algorithm. We only beat 5% for runtime and only 11% for memory. No worries. We'll see if we can do a little bit more to fix this up. As I mentioned before, we're going through that entire list of flights every single time just to find which flights we can take. So let's pull this out and only do this once and then keep a mapping of all of our available flights. So we'll call this the flight map. This is going to be a default dictionary. And it will have a list of indexes or indices. So essentially, we're doing the same thing. For every index in flight in our enumerated flights, let me just grab flight 0. Well, here, I'll just delete this. So for every single flight, we'll just say our flight map for our source, which is flight 0. From our source city, we can append the index, because that will be a flight that originates from this source city. And now instead of calculating all of our available flights down here, we can just say available flights is equal to our flight map for our source city. And we can eliminate all of this extra processing here. Nothing else changes. Let's try that out. All right, and we'll submit this. Hopefully we'll get a little bit of a runtime improvement. Hey, a pretty significant runtime improvement. We beat 46% 46% for runtime and 11% for memory. So clearly there's still room for improvement here. Not the best algorithm, but pretty quick to throw together and try out. So this is the recursive solution. Recursive solutions are notorious for being slow because they incur the overhead cost of calling the recursive function over. Every time you make that recursive call, it's going to cost you something, cost you time, cost you memory. Anyway, this is all for me. I don't have a lot more time left. Hope you enjoyed this. Hope you learned something. Hope you learned a little bit about recursion. I know this was a quick one. Check out the other solutions. There will be better solutions than this one. I recommend checking those out. You can do depth first searches or breadth first searches. I don't know. Check out the other solutions. Okay, that's all for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you write better code than I.